Yes, definitely write it down. So this seems to be a struggle for every student. When you see word problems, you kind of just shut down. So, I know. So I want to take a minute to talk about linear word problems so we can get used to kind of interpreting some words into math problems. So what I'm going to do, these are all patterned the same. There should be 6 questions. This one doesn't have a back for some reason. Okay, apparently there's 5 questions. 6. We're going to do the first one together, and that'll leave you 4 to do on your own, okay? So before we do, I want to talk to you for just a minute. Because these are all linear problems, all of them are going to have a slope. But in word problems, slope is a rate of change. And you can usually see something like change over time. The word per is used a lot. That indicates slope for you. And then you have, we're going to put most of these in slope-intercept form. Oh, hang on. Your y-intercept is what happens when something is 0. So, or when you pay a certain amount of money, no matter how much of a service that you use. So for the problem number 1, let's read through. I think the easiest thing to do is just jump into it. We see that this cell phone company advertises cell phone service for 10 cents per minute. There's that per. Plus a monthly fee. Plus a monthly fee of $35. All right, so the first thing it asked me is to write an equation that relates the total cost of the cell phone bill, which would be y, to the number of minutes you talk, which is going to be x. So if I think about mx plus b, okay, my slope or my per, my rate of change, is going to be what? 10 cents. I'm going to do it as 0.1, okay, because it's 10 cents out of $1. That way my answer's in dollars and not in cents. Does that make sense to you? Okay. Plus, nobody else come up with that, or else it was just too cool. Plus, how much are you going to pay regardless? $35. So here's my equation, okay? 0.1 is the same thing as 1/10. So what's your slope? 1/10. And your y-intercept is 35. So if you notice, okay, so here's my equation. That's part A. Okay, we're going to ask you for the equation. If you notice when you have to graph it, you only have that first quadrant because this is real life. You're not going to use negative minutes and you're not going to be a negative bill. So you're only in this top quadrant here. So now it asks you to graph it. Okay? So you're going to have to kind of think about units on this. All right? As you go to graph. Come over here. Fives would probably work well. Because we need to start at 35, right? 5, 10, 15, 20, 25, 30, 35. Will you have room? Yes. So I'm going to put a point on 35. Okay. And across the bottom, that's how many minutes I use. This is my total cost. So if you actually, we should probably go by tens, y'all. Look at your T-chart on there. What's it got to go up to? 250. So maybe across the bottom, across the bottom maybe we go by tens. Yeah. We got to get up on our X to 250. You see that T-chart that's on there? So it wants you to go from 50 to 250 as you're graphing. So maybe even 50s. 50, 100, 150, 200, 250. That's going to be scrunched in though. 25. Let's go by 25s. Yes. You get a paper? I'm so sorry. Okay. I'm working through this with y'all. So this is the kind of thing you have to think about as you work through them. Let's go by 25s then. I think that's better. 2, 3. So every fourth one is 100. All right. Let's use our equation 1/10 x plus 35. If you use 50 minutes, how much is your bill? What? I went up by 5s going up here, and I went by 25s going across. If you use 50 minutes, so put a 50 here, how much is your bill? If you're paying 10 cents for every minute and a $35 base fee, how much is your bill after 100 minutes? Y'all can get this, or after 50 minutes, I'm sorry. 35 plus, what's 50? What's 50 divided by 10? 5, and then add the 35 to it. Marker. 40. That is correct. Do you see what we're doing? We're plugging in here. So it's 10 times 1/10 times 50 plus 35. 1/10 of 50 would be 5, which would be 40. Right? So at 50, it's $40. How about at 100? How much is your bill at 100 minutes? $45. And so this line is going to go up like this. It's a linear equation. Does that make sense? Yeah, speak up if it doesn't now. So let's finish filling out the table. I hope you can probably do it without doing the math from there once you find the pattern. At 150, what's your bill? 50. At 150, at 200. 55, yeah. At 250, 60. Were you confused? Who's confused? Somebody said I'm confused. You're confused? Where are you confused? Do you see how we came up with this original equation? You sure? Okay. Now, part C is a little bit harder because part C says if Parker's phone bill for October was $87.50, find the number of minutes that he talked. So remember, Y is the bill, so I need to do $87.50 equals 1/10x plus 35. How can I find out what that x is? What do I do? Minus 35. You move that 35. You're just solving for x. Yes, absolutely. This is 5250. How do you get rid of a fraction like that? Reciprocal. Multiply both sides by 10. Ooh, what a phone bill. $525. Or actually, oh no, that's not the bill. That's how many minutes he talked. Yeah. I was about to say, oh my goodness. So he talked 525 minutes. No, his bill was $87.50 to talk 525 minutes. We better switch that plan or something. All right. Questions about that? No, go ahead. Go ahead.